Okay, everyone, I'm wanting to show you two problems from your last quiz. It's the one most everybody had the questions about, the ones I told you I was going to work out for you. And so these were the last two problems on your quiz, number 63 and number 68. And number 63 said this, number 63 said a point P it says moves clockwise around a unit circle starting at 1, 0 for a distance of 26.37 units. They want to know what are the coordinates of P and what quadrants it's in. What are the coordinates of P? What quadrant it's in? Well, what is 26.37? If you're looking at a unit circle and it moves a distance of 26.37 around that unit circle, what they gave you here was an arc length. So what we need to do is we can use arc length because we know arc length and we know the radius of the unit circle. The radius of the unit circle is 1. They told us it was a unit circle. So we can use arc length, the arc length formula, to find the angle and then use the angle to find the point. Well, we know that arc length is 26.37, radius is 1, or 26.37. I keep saying 23. So this would be your angle. Well, remember P, A is the same thing as cosine of theta, and B is the same thing as sine of theta. Remember that from our definitions. So essentially what we're asking here is I want to know what the cosine of 26.37 is, and I want to know what the sine of 26.37 is. When you find those two things, now this is in radians form, so you need to make sure and have your calculator in radians. Here's what you get. You get your P to be 0.3274, and you get your sine to be 0.9449. Now this would be your point P that it's asking for in the problem. So keep that in mind. This is the point P. So that's the first part of the problem that they ask you to solve, was to find P. Okay, to find P. So we did that. Check that off the list. Now they ask you for what quadrants it's in. So in order to do that, we need to take our radian form that we have down here, and we need to change it to degrees. So how do we do that? Hopefully you remember. We multiply it by 180 over pi, which is going to give us 1,510 degrees and some change. 0.89, I believe is what it is. So your goal is to find out what quadrant that's in. So start at 0 and go counterclockwise around your unit circle, how many ever times it takes, until you figure out what quadrant it's in. And when you do that, that's going to be in quadrant 1, believe it or not. Okay, quadrant 1. So that's what it asked for question 63. That's all there was to that one. Okay, some of you overthought that one a lot. be able to do one like that. That's combining all the stuff you learned in these sections in that one problem, okay? That's a good test level kind of question. All right, so the second problem was number 68. And number 68 said there was a circle with its center at the origin that passed through the point 4, 3. Okay, that passed through the point 4, 3. A circle passed through this point. And what they want to know is what is the length of the arc on the circle in the first quadrant between the positive horizontal axis and the point. So you got this point on the circle, 0.43. So they want to know what the distance is right here. They want to know that arc length distance. Okay, the arc length distance between the x-axis and that point is basically what they've asked you. Okay, in problem number 68, and I will open this up for you to review on Tuesday, so you'll be able to go back in and watch the video and it'll make more sense. But the first thing you need to do is find your radius. Now this is A, this is B. How did we relate radius to AB earlier in the course? Well, if you remember, this was our radius formula. So you can take your A and you can take your B and plug it in, and you're going to get your radius to be 5. Alright, well, we've got radius. Well, so think of what we need. We're trying to find the arc length. So here's our formula that relates radius and arc length. So to find the arc length, it's the radius times the angle. Okay, so we have the radius. We're looking for the arc length. We need the angle. So we have A and B. We know what A and B are. So I can take tangent x, which relates A and B. Remember, tangent x is B over A. So that's 3/4. So if I want to find this angle, do you remember how we do that? We did this earlier with the calculator. And I think some of you just kind of forgot about it. But remember, if you take the inverse tangent of 3/4, that will give you the angle. Okay? And it should give you an answer of 0.64350. Now that is going to be your angle theta. Okay? So that's how you solve for the angle. So take the radius and the angle, plug them in your formula and multiply. And you should get an arc length of 3.22. Now your numbers are probably going to be different from mine because all of your numbers are different because they're algorithmic, which is why it takes me a little while to grade them. Okay, but 3.22 for the one I've done. So apply this same stuff to the problem you had, and you'll have the answer. And that's all there is to it. See, 63 and 68. Once you see me work this one out, you're going to think, man, I should have gotten that one right anyway. I gave y'all credit for these two because I felt like there needed to be some more explanation for it. But now you have it, so I'll expect you to get it right next time. Have a great day.